everyone, so we're going to go over lesson 7 today, and you should be doing this on your Chromebooks or on a device since I'm not going to be here today. So this lesson is going to tie into something similar to logarithms, but now we're going to work with a function called ln, which is basically like logs, but instead of having the little number be 10, your little number is going to be a little letter, which is e. And you'll see how it goes in a bit. So e is kind of similar to pi, where it kind of represents a number. So for pi, we know it equals 3.14 and so on. But for e, as it says in the notes here, it's like 2.7182 blah 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 blah. And we're just going to work with that value today. So for this first part, it says we're going to graph y equals e to the power of x and its inverse. So we're going to do this without a calculator. We're just going to do rough estimates. So here we know y is roughly about 2.71 to the 8 to the power of x. So we're just replacing e to the x with this value. And then the inverse, so if y equals e to the power of x, the inverse, we're just going to switch x and y around. So it's going to be x equals e to the y. And how this looks like, it's going to be y equals log e x. But again, just as a reminder, since we're working with the letter e, we're going to use ln instead. So it's going to be y equals ln x. And then here, we could write a letter e here, but if it's invisible, it's just implied. Because for ln, the little letter here is always going to be e. So here, if we were to graph it, so x and y, if we were to graph this one here, so if I plugged in 0, anything to the power of 0 is going to be 1. If I plugged in 1, it's going to be the same number. I'm just going to do 2.7 for now, because since we're graphing it, you can't really see the other decimals. And if I plugged in 2, roughly that's going to be about like 7.4. And then here, for the inverse, all you do is just switch the x and y values. So instead of it being 0, 1, it's going to be 1, 0. Now it's going to be 2.7, 1, and 7.4, and 2. I'm just going to change the color of this right side here, just so when I graph it, it's easier to see for you guys. Alright, so here I'm going to graph this first one, and here, when x is 0, y is going to be 1. When it's at 1, it's at 2.7, so 1, 2, not quite at 3. And then 2, it's at 7.4. So 1, 2, 3, 4, 5, 6, 7.4-ish. And when you draw it, there's no exponent or x value that will make this number going to be negative. So the number's only going to get smaller and smaller. So it'll never approach, or it'll never touch 0, but it'll keep approaching it. And here, I missed. And here we see it grows exponentially, where it just keeps getting higher and higher. But again, it'll never touch 0. So if it never touches 0, that means we have a horizontal asymptote here. So here, HA at y equals 0, that's an @ sign. And now, since it's the inverse, instead of being a horizontal asymptote at 0, we're going to have a vertical asymptote at y equals 0. Or at x equals 0, sorry. So here, I'm just going to draw that right away because we know that's going to happen. So here, VA at x equals 0. And now I'm just going to graph the right, or the green chart here. So when x is 1, y is 0. When x is 2.7, y is 1, 7.4, 1, 2, 3, 4, 5, 6, 7, it's at 2. And now, it's going to look like this. So make sure you label your graphs if you ever asked to graph more than one function. So here, this is going to be x equals EY. And this blue one here is going to be y equals e to the x. And then you're done. So here, down here, facts. So these are kind of like rules, and it's very similar to what we did in previous lessons, except instead of having it say logs, it's just going to say ln. So here, ln a over x, division rule, same thing. So it's going to be ln a, because the a is positive since it's in the numerator, minus ln x. X is negative because it's in the denominator. Multiplication law, ln a times x equals ln a plus ln x. Power law, ln a to the x equals x ln a. And then ln 1, that kind of looks like a face, ln 1 equals 0, because in order to have anything equal to 1, or it's just going to be exponent of 0. And then this last one, ln e, is going to be equal to 1. Because, for example, here, if we have the little number and the base the same, it's going to be 1. This is kind of similar to when we saw like log c of c from a previous lesson. But that's it for the facts. So now we're going to solve for x. So this is kind of like last lesson where we just solve for x when given an exponent, but you know you have to use ln when you see the letter e is involved. So here we're just going to add the word ln to both sides, very similar to last lesson. So here, ln, well that's fine, ln bracket e to the x equals ln 2x plus 1. So one thing I want to note again, even though this right side here doesn't have an e, you still apply the term ln to both sides as long as one side of the equal signs has a single e anywhere. So now we just do our power law and we move all our exponents to the front. So x ln e equals bracket x plus 1 ln 2. So one thing I want to note here, a lot of students tend to divide both sides by ln e to isolate. You can do that, but that's gonna be a waste of time and space because ln e, as we see earlier, so I'm gonna put a little cloud around it, is just equal to 1. So realistically, this is just x times 1 because of the rule we saw earlier. So I'm just gonna draw a little arrow just so you know what happened. And I'm just gonna FOIL the right side here. So x ln 2 plus 1 ln 2, which is just a regular ln 2. And then now I move all my x's to one side, so I'm going to move it to the left, so x equals, wait, I forgot to move it, x minus x ln 2 equals ln 2. And then now we factor out x, so when you factor it out here, x divided by x is going to be 1, so you have to include this 1 here. Do not put 0, there's going to be a 1 here. Minus ln 2 equals ln 2, and now x equals ln 2 divided by 1 minus ln 2. And when you plug this into your calculators, it's going to be x equals 2.259. And that's it for this question. So again, it's very similar to what we did last lesson, but the only difference is instead of having log, we have ln. So that's why we're not going to do that too many examples today for that concept because it's very repetitive. The only difference is there's the letter E, which means we use ln instead of log. Now, letter B. So letter B is basically the same thing, except now, since our argument has a bracket and like a little equation inside of it, we had to check if it's an extraneous root. So here, ln, oh man, I forgot to press it. ln bracket x plus 1. I'm just gonna move all the ln's to one side on the left and all my whole numbers to the right. Minus ln equals 1. So we've been used to practicing having the term log or ln on every single term, But you have to remember that there are going to be some questions where you're given just a whole number. If you are given just a whole number, that means you could just solve for the argument. You don't have to solve necessarily for both ln's or both logs. You'll see what I mean. So here, I'm just going to combine the left side into 1. So there's a minus sign separating both the ln's. I forgot the x here. ln x. So if there's a minus sign separating them, that means you use division law. So it becomes a giant fraction. So ln bracket x plus 1 over x equals 1. So now, here, you have to remember there's a little e attached to here. So now we do the little switch method. So now, we write e, the 1 gets attached to the e now, and then now our argument goes on the right side, so they kind of switch places. So now we have x plus 1 over x. So this is kind of like the concept or the little swoop method where I make the little heart in the air with my fingers, but they just kind of switch places. So again, the e gets attached to the 1, and the argument goes on the right side. So now we want to solve for x. So here, we want all the x's to be in the numerator, so we're going to multiply both sides by x. So it's going to be ex equals x plus 1. And then now, we're just going to factor out x. Or wait, sorry, we're going to move all the x's to the left side. So we have ex minus x equals 1. So now we factor out the x, so x e minus 1 equals 1. So again, we just factor out x. Do not divide the whole thing by e, because that's just going to make it more complicated. So I'm talking about this step, so a lot of students tend to divide everything by e here. You can, but just a little extra steps that you don't need to do. So here we have x bracket e minus 1. Now we divide both sides by e minus 1. And that's going to be your answer. So here, if you plug this into your calculator, you should get 0.582. And we check, is this an extraneous root? So if you plug 0.582 in for x, both of these are going to be positive, because 0.582 plus 1 is positive, positive. So there's no extraneous root. So I'm just going to write this a little note, so when you're reviewing this, no extraneous root. And that's it. So now we're going to get to everyone's favorite, word problems. So here, I just want to break down what are key things you should look at for word problems. And what do they represent? So here, the value of v in dollars of a printing machine is decreasing. So decreasing, keyword, exponentially, according to the equation v equals 85,000 e to the power of negative 14t, where t is the time in years since the machine was installed. So one thing I want to note is that if you ever see a number attached to the e here, that's going to be your starting value. Because if you switched the letter t here in this equation to 0, so like whenever anything starts, the time is going to be 0, right? So if you plugged in t for 0, that whole exponent turns into 0. E to the power of 0 is 1, so 85,000 times 1 is just 85,000. So this number here is always going to be your starting value. But anyway, so here, find the value of the machine after 10 years. So 10 years, do we think that's v, which is dollars, or t, which is time? In this case, it's going to be t is in time, as in time. T equals 10. So all you do is just plug and solve. So we're looking for v, the value, so v equals 85,000 times e to the negative 0.14 times 10. And then when you plug that into your calculator, you should get, put a dollar sign because we are working with money. So it says v in dollars, so you have to put your units. So in this case, it's money. So it's going to be $20,960.74. So you could do this where you have the dollar sign in front, or you could write oops, I wrote the dollar sign again. Or you could write $20,960.74. So either one is fine. One thing I want to note here is so many students tend to put 3 decimal places because they're used to that, but you have to think of the context here. So when you're at a store, do you pay for things with 3 decimals? No. You should only have 2 decimals max. So money is 2 decimals. So please remember this, because they don't really talk about this in textbooks and stuff that much, but this matters for the exam. So they don't tell you round to 2 decimal places, but it should be common sense for students, and a lot of students tend to forget this, so I'm just here to remind you. Anyway, so letter B. Oops, I forgot. Box your answer. So letter B, after how many years will the machine be 25% of its original value? So what are you looking for? Are we looking for V or are we looking for T? So here it says how many years. That means we're looking for T. But you might ask, Caitlin, but what is the value of V then? We can't be looking for both of them. Well, you have to just do slight calculations for it. So here it says the machine will be 25% of its original value. So 25% in decimal form is just going to be 0.25. So whenever you see a percentage, there'll always be a 0 in front of it. For example, like if I give you like 96%, that's just 0.96. If I give you 4%, do not write 0.4. This would be 0.04%. So it's always going to be like some form of a 2-digit decimal. But that's just a little tip. If this is a little confusing for you, I could go over it in person. But yeah. So anyway, continuing on. So here, we're going to multiply something by 0.25. So we know our equation is going to be V equals 85,000 e to the negative 0.14 t, and we're looking for t. So 25% of its original value. Original value is kind of like a synonym for starting value. So here, all you're going to do is you're going to take your starting value, which you said earlier is 85,000. So it's going to be 85,000. And you're just going to multiply this by the decimal number here. So here, 0.25. Because if you multiply these two things together, it's going to give you 25% of that number. So here, do not simplify this yet. You'll see why. So I'm just going to rewrite the right side now. So we want to get E by itself here, right? So in order to get E by itself, or sorry, we want to get T by itself. In order to get T by itself, we want to bring it to the front. But there's an $85,000 attached to the E. So you're going to get rid of the 85,000 first. So here, you're going to divide both sides by 85,000. So that's why I didn't get you guys to simplify this yet, because now it makes your math a whole lot easier. Because the 85,000s now cancel, and now you're left with 0.25 equals e to the negative 0.14 t. And now this is a lot less intimidating to work with. So when you're at this stage where you're left with just a single e on one side, now we are going to attach the word ln, because we can now try to move the t to the front. And in order to do that, again, we need to attach ln to it. So here, ln 0.25 equals ln e to the negative 0.14 t. That's an ugly bracket. So here, again, just to repeat myself one more time, if we want to move t from the exponent spot to the front, we have to attach ln in this case, not logs, because we're working with e. So now we have ln's, now we can move the t to the front. So it's going to be ln 0.25 equals negative 0.14 t times ln e. But you have to remember, what is ln e equal to? So ln e is equal to 1. So actually, you don't even need to rewrite that because this is 1. So you have to remember that. So now we have ln 0.25 is equal to negative 0.14 t. So again, the ln e is really realistically just 1, so you don't have to rewrite it. And then now, how do we get rid of the negative 0.14? We divide it. So here, ln 0.25 divided by negative 0.14 is equal to t. So t equals 9.902 years. So do not forget units. Units matter because that's worth half a mark, and especially for word problems, you always want to have it. So since it's a word problem, you're going to write a sentence. So it will take 9.902 years. And then the sentence for letter A is the value would be $20,960.74. But yeah, again, for word problems, you always want to have a sentence just to be safe. You don't want to lose a free mark. So one thing I want to note is, would it make sense if, let's say I got t as negative 200? No, it would not make sense because you can't go backwards in time. You're not going to say it takes negative 200 years to get this value, right? So you have to think logically, does my answer make sense? But that's it for this word problem. So now we're going to go to the next one.